So now we're in position to look at some of the substrates for atrial arrhythmias. This is a human heart that I've opened through the superior cable vein so that you can see the terminal crest, the muscles of the appendage, and the opened tricuspid valve. And this shows you very beautifully the macro reentrant circuit which we know to be responsible for atrial flutter. And we know the commonest form of atrial flutter takes a counterclockwise loop around and down the terminal crest, turns in to the vestibule of the tricuspid valve, passes up the vestibule in front of the oval fossa, which you see here, and returns up to the terminal crest. Now we also know that within this circuit there is an area which can be ablated, and that area is the so-called isthmus. And this heart has been dissected to show you the arrangement of the isthmus. This is the eustachian valve, and we can see how the eustachian valve continues as the tendon of Todaro, which runs forward to insert into the membranous septum as one of the boundaries of Koch's triangle. Here is the coronary sinus, and there, inferior to the coronary sinus, is this crucial isthmic area. We know that the isthmus has three parts. It has a posterior part where the terminal crest breaks up into trabeculations. It then has a much thinner membranous part immediately underneath the coronary sinus, so a sub-Thebesian pouch, because the Thebesian valve guards the mouth of the coronary sinus. And then you see how the fibers, we've removed the endocardium from this specimen, turn upwards into the vestibule, and this is the smooth vestibular area, and this is always also the slow pathway into the atrioventricular node. And it is this entire area between the eustachian ridge and the tricuspid valve which forms the isthmus, and this is the area where the electrophysiologists place their lesions so as to divide the commonest type of atrial flutter.